Hello and welcome to Math 252 Calculus 2 here at Cañada College. My name is Lapuz. In this video we'll be doing checkpoint 4.6. This is the last checkpoint in section 4.1, our introduction to differential equations. So here they tell us that the rock is falling from rest at a height of 100 meters above the ground, and the only force acting is its gravity. Find the equation for the velocity v of t as a function of time measured in meters per second. All right, so we will start off with a differential equation. The velocity, the derivative of the velocity, so our differential equation, the derivative of the velocity is equal to the gravity. So that's the force that's happening. All right. So we can write this as a differential equation that says dv dt is equal to whatever the gravity is. It's, I think in meters, it's negative 9.8 meters per second squared. It's per second squared. Yes, so meters per second. I think we just call it S. Okay, so that is essentially that's our differential equation. We can rewrite this as v prime equals negative 9.8, which is kind of fairly simple. Now we have, this is your differential equation. Now we need, we don't need, they give us an initial condition. And the initial condition tells us where we are at time 0. So where we are at time 0 is going to be, well, it's 100 feet. I guess it's not where we are, but what is v at 0? So v of 0 is coming from rest. So this is from rest. So there is no speed or no velocity because this is falling from rest. So 100 meters is a position, but that's not the velocity. We need some information about the velocity since we're looking for the velocity function. So we're actually not going to care about 100 meters. We are going to care about the fact that the velocity is 0 as your initial condition. Okay, so that is the problem. And what we'll do is we'll solve for this by, again, taking the derivative and just casually throwing the integral sign there. Is kind of like what we're doing, but there's more going on happening there. So if we take the antiderivative of the derivative, then it's just going to be the original function, and then this is going to be negative 9.8 times t plus a constant because these are indefinite integrals. And now at 0, v of 0 is going to be negative 9.8 times 0 plus c. That is supposed to be 0 according to the initial condition. Well, 9.8 times 0 is 0, so that means c is going to have to equal to 0 here. So then that is it. Our velocity function is going to be given by negative 9.8 t plus 0. And that is your answer. All right, I hope that helps. Good luck.